Good morning, everyone. I hope everyone is doing okay and can hear me fine. I'm really excited to be back here after vacation, much needed one, I would say. And I miss you all, and I hope everyone would be having good time and ready for another session. I have Purna with me today, and she would also be helping with the chat questions and would be helping with the guest session we would be having. So, from today onwards, we are embarking on our behavioral track. But I have included a little bit of technical too because we had some questions for specific services which people struggle with. So, I thought let me talk about the basics of the technology first, and then we will have a guest who would help us in understanding how their journey was, what they have achieved, and how they achieved it, and some tips and tricks to help you out. We have a nice guest lineup coming up. In next week, you will be revealing the name of all of those people, and probably we would have a workshop from recruitment team of AWS helping you understand how the recruitment process works. We are also looking to get some hiring manager on the call so they could help you in understanding how the hiring process looks like, what they look into candidate. I know that currently that we do not have recruitment opened, but when it opens, this skills would help you, and we will focus on more interesting stuff. So, as always, enjoy the session. Any feedback, we are all open for it. Any suggestions you have to make your learning better, just let us know, and we would be happy to help you with that case. Parna, if you are there, I would just like you to say hi, and then we can connect. We can move forward. So here is Parna. Thank you for your time, Parna. And if you know,
Hey, hi
Parna has
everyone.
now joined us as a PESA volunteer and she is helping us with a lot of session. I enjoyed your last session on networking, Parna. It was good. I really enjoyed it. I couldn't catch up everything that day, but I later watched broadcast and it was nice. So thanks for that.
Thank you so much. I'm sure everybody missed you, so they were surprised to see me rather than you there.
Yeah, we need change, isn't it? We need changes
Yeah,
sometime. Yeah, means
right.
I was daring for that vacation from long time, and due to some commitment I could not go. But yeah, that was a nice time. Thank you. So we will quickly get started, everyone, and feel free to ask questions. We can see people are less in numbers. That is completely fine. Commitment is not something everyone can do. Everyone has their priorities and then other things. But yeah, anything we can do to make your learning better, just let us know, and we would be happy to accommodate those things so that you get the best out of the session. We respect the time you're investing and we want to give you the best out of the time you have. So any suggestions like this technical session which I'm taking right now shortly is based on the suggestion we received for Amazon ECS. Similarly, if you have any other services which confuses you, and if I know about them or anyone in our team knows about it, we would be happy to discuss those things. All right. Thank you. Thanks, Rajshekharan. Vacation to India? No, I went to Dubai, Ranga, this time for a week. So I plan to go to India next month for a long vacation, but I wanted a short trip to just to unplug, and that's why I went to Dubai for a vacation. I've been working there for 4 years, so I have a lot of friends which I wanted to talk to, and it's been long, so that's why I went there. But yeah, I'm looking forward to my vacation to India. Thank you. Let me share screen and we will quickly get started. Let me know once you see the screen. I hope everyone is seeing the screen. So I'll go off camera and let you focus more on the content so that you get the best of the particular session. I'll switch off this banner also. Yes, we have started the session. So we are on week 9, 8th April, and we will discuss about container stuff, right? This is purely based on the request we have received for somebody wanted to learn about containers. So we are happy to accommodate that. Now, I have covered containers before in a different session, so I won't go into much detail, but I would now talk about the implementation details of the container. Let's go ahead and talk about it. So how containers run. So container basically share an operating system. Let me give you an idea how it actually happened. So in early days, we had a traditional approach where you had a physical server, and on that physical server, we had operating system. That operating system would allow me to run application, and that's how we were running our resources. So that was the easy way to get started, not a complicated one. And then came hypervisors. In hypervisor, we started having an operating system, and that operating system is hypervisor operating system, means it's a specific purpose built operating system allowing me to run virtual machines on top of it. And when these virtual machines are running, I am able to host multiple virtual machines on the system, and I am leveraging my hardware in a much better approach. Container work on similar approach but little differently. Let me explain. In container, we still take the traditional operating system like old days, and instead of physical server, this could be virtual server also, but we need some power of compute to get these services running. And on this operating system, we install some container platform. And that container platform could be anything. The most common one we see is Docker, but it is not the only one. There could be LXD, there could be Rocket. So there can be multiple types of container platform depending on your comfort, depending on your use cases. You would select any of these container platform, and afterward, once this container platform is ready, you would then add containers to it, and that's how your application would be running. So container are a micro virtual machine in a way. They do not have their own operating system, but what they do, they share the operating system. So virtual machine, I call them that it is a hardware virtualization, but in case of containers, we call it that we are doing a operating system virtualization. My operating system is virtualized, and multiple container feel they have full control of operating system, but technically they are just sharing those operating system. So that is what the container approach looks like, right? Any questions so far on containers? Anyone, any doubts? I have a session into previous batch, so please check that to get more detail. I just quickly covered it, and now my focus would be more on container services on AWS because there are a lot of them. So I want to ensure that you get an idea on when to use which one and what purpose each service solves of containers in AWS. Okay, keep your questions coming, and we will try to pick up those questions, and we will try to answer as much as we can. So let's try about talk about containers on AWS. Now, we need two type of services to run it. September 2022, it was covered. Yeah, thanks, Pawan. So we have two things we require. One is image storage. Image is a container requires an image to get started. So we need to store images. And second we need is compute. Compute is basically where we would be actually executing these images or running these images. So image storage, which we have, is called ECR, Elastic Container Registry. And through this Elastic Container Registry, we could keep our images. This is used for storing, encrypting, and managing container images. Not a mandatory service, but highly recommended if you want to have a private control on your container images. Put them into ECR, and this ECR service would allow you to create something called repository. Like you have Git repositories where you keep your code. In a ECR repository, you would keep your container images. Obviously, if it is an image, it can have multiple versions also. So you could have versioning done on your container, should not be a problem. But this is an image, this is a definition which needs to be executed somewhere, and that somewhere is basically compute services. So compute can be provided to containers by a traditional approach which we use EC2 hosted. Means I would have EC2 machine who would allow me to have a compute capacity provided, or if I feel I'm not interested to maintain these EC2, I could go in a serverless approach. And in serverless, I would just say, hey, this is my container, I need that many copies of it, I need this much memory, and then the service would take care of deploying that container for you. That would be serverless fashion. And in serverless, the service we offer is called AWS Fargate. So Fargate would allow you to run containers without managing the server. I don't have to worry at all about anything, and I just say what my image is, what size I need, and what how many of I need, and it will be taken care by the service. Like when you execute a Lambda function, you just say this is my code, this much memory I need, and service takes care of providing the resources. Similarly, in Fargate, you specify container image, and you would be just getting those services running without you managing any infrastructure. So that is a serverless way of running your compute. So this is good, but sometimes we need more control. Sometimes we want to install some specific software on those hosts where the container is running, maybe a monitoring software like Prometheus, maybe a networking software like Calico. So we need to have control on it. And that time we could go with the approach of EC2. What I could do, I could create a self provision cluster on EC2. So I could take my EC2 machines, and on those EC2 machines, I could install the Docker software. And once the Docker software is available, I could put them together into a cluster. And when that cluster gets ready, I should have no problem in running more services on top of it. So this is one good way. This gives me more control, but the challenge here is that I have to manage this software. I have to install Docker, dependencies of that, keep it updated, lots and lots of challenges. So this is still a better approach if you want to have server level control for your operating system. Somehow you need to install some third party agent, or you need some component to be configured or tweaked as per your requirement, then you would be using this container based approach. If you do not want to maintain these things on your own of installation and provisioning, you could take help of a service which is called ECS, which is our Elastic Container Service. And that is the topic for today, which I want to discuss. And in ECS, you can run containers using fully managed container orchestration service. ECS is a service offered by Amazon AWS so that you do not have to worry about installation and configuration of initial container images. We will be taking care of that for you. So that is one approach. I could run container using a fully managed container orchestration service. Or if you feel that I have expertise into Kubernetes, or my existing environment was Kubernetes, I may use a Kubernetes based cluster EKS, and that would be hosted on EC2 machine, and through that I could manage container with Kubernetes. So this is another approach I could follow if I have to. So these are the options available for me to run containers. Now ECS EKS are basically a orchestration tool. What I mean by orchestration tool, that they help you in deciding which service to use, or which image to configure, or how to deploy that image. If a container fails, how to restart that, or how to recover from a failure. So they basically orchestrate the common task of placement, restarting, configuration for you. So those are considered as your orchestration service, but behind the scene, they are still leveraging EC2 based machines on that case, right? So I hope this thing is clear and you have a better idea on how these all services put together. If there are any questions, any doubts, any confusions, let us know and we would be happy to answer those questions for you. So this is what we can do for running containers on AWS. Now let's see how implementation looks like. So we will be comparing EC2 versus containers. So that would be much easier for you because most of you already know about EC2 machine. So in EC2, when I have to deploy something, how my journey looks like, and I would compare that journey with containers here. So to get started with the EC2 instance, I would need an AMI, right? AMI, anyone knows full form of it? What is the full form of AMI? I'm sure everyone knows about it, but yeah, just to make an interaction here, anyone, what is the AMI? ECS is backend in Kubernetes on any other software. We'll talk about that, Siva. So we will talk about that. AMI is Amazon Machine Image, exactly. So that is Amazon Machine Image. Now Shiva has a question. ECS is backend is Kubernetes. I would say probably no. No. No, see, it is not Kubernetes. Maybe it is something which Amazon has built in on their own, or it may be it may be Docker Swarm. I don't know, but this is not Kubernetes. I can guarantee you that Kubernetes is only for EKS. So when you deploy EKS, that time Kubernetes is there. This one is still using maybe a proprietary version of Docker Swarm if required. Right, so that is possible, but not EKS running here, not Kubernetes running on that case. Another question I have here is container are scalable? If yes, how? We will talk about that and we'll see that in a minute, Sundam. So Sunanda, we will be talking about that, how we will scale them. So my AMIs are stored into S3. We do not see that, but actually these AMIs are being stored into Amazon S3 bucket somewhere that is maintained by AWS. And then when I have to use these AMI, I would be putting them into an instance. So when I say I want to launch an instance, I have to define what is a AMI, what is the CPU and memory requirement of it, what role I have to assign, what network it would connect to, how much storage would be there. So we would be using this as a mechanism to launch EC2 instances. So we would need AMI, we will put together into an instance, and then it will be started. Now, challenge here is if it is one instance and if it fails, my service would be stopping. I don't want that. So probably if you are looking for high availability and performance, you would put that together into auto scaling group. So in auto scaling group, you define what is the group of instances, how many you need, what is the minimum maximum, what is the health check, what is the deployment cycle of it. So all this information is put together into a auto scaling group. An auto scaling group is a definition. It will still need a execution environment to get started. And that execution environment in AWS is provided by Nitro system, which is our purpose built hardware software combination. And once you have this Nitro system, then you could have your auto scaling group running on top of it. It could be ASG1, ASG2, and we can maintain minimum, maximum, and desired capacity inside it. But I don't want my users to independently talk to these machines. So most probably what you would have a load balancer where user interact, and that load balancer forwards traffic to the auto scaling group in which any of the auto scaling instances can respond to you. So this is properly how your EC2 instances would be running. Keep this concept at back of your mind, and let's relate this concept with our ECS as a service. Right. So in ECS, what we would have a container image. This container image is equivalent to a AMI, which is a definition of what I want to launch. As AMI was stored in Amazon S3, a container image can be stored in Amazon ECR, Elastic Container Registry. This is a definition, and this definition has to be provided with the details, and that detail we would provide through something called task. So this is a keyword for ECS. ECS uses a mechanism called task, and which is a combination of one or more container, and in that we define how much is the image size, memory, role, network, or storage. Similar like an instance, it is a task we are creating. If you want, you could just launch one task and get started, but most probably one task, if it fails, your request will not be succeeding. So what you will do, you will combine them together into something called a service. Another technical term we use here is called service, and service is combination of multiple tasks. It is like an auto scaling group of the task in which similarly we define deployment type, health check, configuration, minimum, maximum, and this is what we call as a service. Now this service has to execute, right? It has to run, and it would require an execution environment, and that execution environment will be provided by ECS cluster. If I want to have a specific hardware specific type of operating system, ECS, that is, if I don't want to manage all these things, I need orchestration, I would go for ECS, and then I may have services running on top of it. This is a standard approach where I have a cluster in visibility and I run my services on that. I control the size of the cluster, but what would happen here, that Fargate is ensuring that Fargate will allow you to run service without managing the server. So both are execution environment. Services can be configured to run on ECS, or it can be configured to run on Fargate. It is purely up to you. And once you have these services ready, again, they may be individual system. So maybe we will put a front end on that. That would be a load balancer. And now my users would be connecting to that. That's how it will be working. All right. So I hope this thing is clear and you have a better idea on how all these things work. So as you could see, there is not very different way of doing things, only the terminology changes. There we used to call that instances. This time we call it task. Here we used to call it auto scaling group. Here the wording is service, and we used to run it on Nitro system. Here we run it on a ECS cluster. So that's how things are created. I hope this thing is clear here. Okay. I have a question here from Sunanda. Let me check the question here. AWS Nitro system doesn't make any instance have high availability. No. Nitro is part of the AMI definition? Answer is no. Let me talk about Nitro definition. What is Nitro and why we need it? Now, what AWS is doing, AWS has taken some physical servers. Right, let's talk about how everything works. On these physical servers, what they have some custom built operating system running. You could call it a hypervisor. Initially, it was a Citrix type of, initially it was an open source hypervisor called Zen hypervisor. Now, EC2 came in existence in around 2006, 7 or sometime. I don't remember exactly, but point I'm trying to clarify here is that EC2s are running for a long duration, more than 15 years. So till that time, AWS realized that what is the optimal configuration in terms of hardware and software required to run EC2 instances. So instead of taking any traditional server and any traditional operating system, what AWS did, AWS realized that it will be better if we build our own system for running these EC2 machine, which will be fine tuned for EC2. This is a purpose built type of operating system, which will purpose built type of hardware and software combination, which is allowing us to run EC2 optimally. Hardware means it has something called Nitro chip, which is a hardware based virtualization, and software is it is having its own hypervisor, and that combination is called a Nitro system. And whenever you launch a EC2 machine, those EC2 machine are launched on this Nitro. So Nitro is the hardware software combination. It is not by default making your application highly available. You would decide on auto scaling group or other configuration by which you would be creating it. Chip from AWS or Intel, I don't know, Ranga. I'm not sure. Maybe some component, maybe from different vendors, but maybe it could be all AWS. So see, that detail is not published because it doesn't add to any value to the customer. So we do not have that information here, right? So hopefully this thing is clear. So Nitro is not part of our AMI. AMI is a configuration, and you launch AMI on a Nitro system, and that's how it actually works. I hope everyone is clear. And let me quickly go to console so that we can best leverage the time. And afterward, we would be seeing this ECS into action. So my requirement is pretty simple. What I am looking for a specific server to be, so I want to deploy some container which will be just a simple web service containers I need to. So for that, what I would be needing first, I would be needing a cluster where the containers would be started. So I would have two-step approach. First, I would create a cluster, and once my cluster is ready, then I would launch containers on that. Question is here. Let me read it. Service in container if equivalent to ASG instance, would it be right to say service responsible for scaling containers? Yes, exactly. We will be talking about that, and I will be showing you that also. So yes, exactly. That is a true understanding of yours. That it is a right understanding. I'll show you that in a minute. Now, I'm just going to ECS service here, Elastic Container Service, and through this service, I should be able to first get started by creating a cluster. So cluster is a combination of EC2 instances on which I would be running my container. So I could go ahead and create a cluster here. So this is my cluster. I do not have anything. I'm using Northern Virginia. Now, for sake of demo, I'm not following best practices of keeping it secure and putting it into internal network and all. I'm just creating a cluster for sake of it. So let's call it, this is my ECS cluster 01. That's what I want to create here. I would need a VPC because basically it is EC2 machine behind the scene. So I could select which EC2, which VPC it will be part of, which subnet it will go into. I have multiple of them selected. Maybe I am not interested in all of them. So I just selected two subnets for it, but you could spread your cluster across multiple subnets, should not be a problem. And here in infrastructure, I could specify whether you are using what for that, whether it is going to be a EC2 instance, or is it going to be external instances using ECS anywhere. I'll explain a little bit on ECS anywhere in a minute, but let me start with EC2 instances. What I'm looking for, I am looking to create a new auto scaling group. In that, I would be having Linux based instances. So this is my Linux 2 operating system, which I have selected. Instance type, I am looking for, let's say C5.12. two extra large instances. So I could select this C5.2 extra large instances, and here I am specifying minimum 2 and maybe maximum of 6. And if I need to SSH, I could select the key pair. If not, I could just keep on removing it, and then I could go ahead and say create. So when I say create cluster, what is going to happen? A cloud formation template is going to be kicked in for me. And that cloud formation template would set up a auto scaling group with two EC2 instances with required configuration, required networking, and that is how my cluster would get ready. Cluster will give me the basic architecture on which I should be able to launch my EC2, launch my container images. So if you look here, this is the template which is being used for your service, and this template has information about what is happening. Plus you would be able to see things into event section, like what is currently happening, what resource is getting created. So you could select it and you could see this process as it is happening. So I'll keep it running until that time. We will focus more on some additional thing, which is the task definition. But for EC2 launch time, we need Linux. Answer is no, Sunanda. So that is a question which is there. Let me put it on the screen. But for EC2 launch time, see, you need an instance or you need an operating system which has Docker installed on that. So you could have selected a Windows based operating system too, and that may be also a Docker system. So that is not mandatory. The most suitable option is Linux, but if you want, you can run containers on Windows also. So container is in a way platform independent, but you platform independent doesn't mean that. Let me explain that. So when you create a container image, in that image, you specify whether it is a image to be run on a Linux based machine or a Windows based machine. So that container image you could run on any flavor of Linux. But you can't say that I would take this Linux based image and run it on Windows. No, it is not that kind of independence. It will be having independence in the flavor of Linux or supported Linux platform, but you can't say that my image is having Windows based information and I want to run it on Linux. It won't work. So compatibility doesn't mean cross operating system. It depends independence from the platform independence of your uh, Linux flavor, but not Windows or EC2, Windows or Linux. So I hope this thing is clear. All right. All right, keep your questions coming, and that is, yeah, that's good. That's not a problem. So see this now. My cluster is getting ready. We have two instances currently being registered. My cluster has been created. If I go back and see, it has created it. What it has created for me, it has created a ECS cluster, and in that ECS cluster, I have two instances which are part of my auto scaling group. If you see, auto scaling group got created, and now I could see this cluster here and see what is the status of my instances. So here is my infrastructure, and in infrastructure I have two instances which are basically just EC2 instances, nothing complicated, but internally they already have this agent installed. This is a ECS agent. So this ECS agent would allow me to manage these infrastructure through ECS. So this is my cluster ready. And if I want, I could even register external instances. So what is this ECS agent? Let me explain it. So this is a plain EC2 machine, right? On this EC2 machine, there would be a Linux based operating system. On top of it, there would be Docker or any other software for container. And also on top, we install something called an ECS agent. This agent would be allowing us to manage these instances. And what you would have, you would not have one instance, you would have probably multiple instances, and that will all have the same type of things inside. Every of these EC2 instances will have a ECS agent, so you could create a cluster out of it. So what I could do now, I could put all these machines together and call it a cluster. Now we have another service which is called ECS Anywhere. Very simple to understand. What if I have a on-prem infrastructure or I have an on-prem machine in my own data center or on wherever? So this is my on-prem server. What I could do, I could install a ECS agent on this on-prem server also. Let it have connectivity to my AWS services, and they can also be now part of my cluster. That is called ECS anywhere means the agent is running anywhere and we can control it through the control plane of ECS service. So that is also possible. So you decide on what works well for you. You are not limited to have ECS only in on-prem, only in AWS. You could even run ECS agent in on-prem environment and let them get registered here so that we could treat them as part of a cluster. So one place you could say, okay, I want to launch some container on on-prem, or I want to launch some container on EC2. So that's how it would be working. I hope this thing is clear and you have a better idea on what is ECS anywhere. Okay, let's move forward. Let's discuss a little bit more on that. So once this is ready, my cluster can handle the request which is coming up. That's fine, but I do not have anything running on it as of now. So that will start with task. So in task, I would define what I am looking for, right? I have some task here. Let me delete it so that we don't get confused with it. So I would be needing to go inside it and then I would select different versions of it and we would be saying deregister them first. And once deregistered, I would be able to delete it. So that is deregistered. This is my task definition and I do not have anything inside it, right? So I could now create a new task definition if the need be. So this is my task. And in this task, if I need, I could have containers running. Let me go ahead and create a task for you first. Let's create it. Let me remove this one also so that you don't get confused with the UI. And let me deregister. Done. See what I'm doing? I'm deregistering. Done. And now I have nothing here. Let me start with create new task definition. We can have multiple container running on single EC2 instance, right? Yes, exactly. See, we would have a capacity from EC2. So if you look at these EC2 machine which I have, these instances giving me that much of CPU and RAM. So if I have this instance, it would have some amount of CPU and memory associated. So this is C5.extra large. Probably it will have 8 GB of RAM and 4 CPU. So till I fill up that space, I should be able to utilize them and run multiple containers on that EC2 shouldn't be a problem at all, because that's how we will have a dense deployment and we would be able to leverage these instances at full capacity, because my containers can be very small in sizes which may not fill up the whole instance. So obviously I could have multiple containers running on a single EC2 instance, no problem at all on that, right? Okay, now moving forward, what I'm trying to do here, I am trying to create a task. Let me go ahead with the task definition. It is information about the task. So I call it, let's say I want to run a simple web server task. So I have a task. Task is the outer boundary. In a task, I define which container I want to run, right? So I say I want to run a web server here. Okay, what web server is? So I would say I want to utilize here HTTPD and I want to use this latest image. Now, what I am using here, I am using the Docker registry, which means that is a free template available from which I could get this HTTPD image and I want to use latest image version of it. If you want, you could replace this image URI with your own container image. So you should be able to have your private container images and that ECR images can be referred here. Right now, I'm just saying that, hey, I just need to have it being downloaded directly from my public repository. I'm not looking for internal communication, not looking for internal repository. So that is completely fine. And now I could see which specific port number we would be referencing to. So what is happening here? This is your instance, right? On this instance, we may have containers running. So instance would have a network interface, right? So let's say this is a network interface of an instance, and in that we have multiple containers running. So when a request comes on port number 80 here on a ENI, I want it to be forwarded to one of my container who would respond to me. And that can be running on a different port number. Let's say it is running on 8080. Similarly, I could say if a request comes for 443 port number, I want to forward it to another container who is running on 443. So that mapping can be created, that network configuration where we receive requests in one interface, but based on the request port number, we forward it to different type of containers running inside. So that is completely possible. What I'm doing right now, I'm saying I am okay with AT and TCP port number. I do not need more port mapping. I could add environment variable, like if my container wants to go and talk to a database and I need credential for it, I could have added it. And any health check and any specific Docker configuration or commands I want to run, or I want to set up a working directory, I could have done it, but I want to keep it as simple as possible. So I am creating a simple web server task by referencing an image HTTPD latest version of it. I may have to define little bit more details on it. So this is my task has been successfully created, as you could see. Now I have this here. I say where I plan to run this task. So my request here, or my suggestion here, is to run on EC2. I want to run it on EC2. I'm not looking for Fargate as of now. I could select the architecture. I could define how much CPU and memory I want to give to this particular task. So I don't need 3 GB RAM. One CPU and 1 GB RAM is okay. But if you want, you could set up even smaller sizes on that. So maybe 0.25 CPU, zero point 0.5 CPU, or maybe smaller amount of RAM. That can also be done, should not be a problem. So we could define that. Now, this is a task size. One task may have multiple containers. Let me explain that. This confuses people. So most of the time, in one task, we keep one container, but it is not mandatory to have one container. What if this is my web server and I want to have another container in that who would be doing the log processing? So it is still one task, but I have one container for web and another container for log processing. They both can work together as one single task. So I could define memory and CPU for task level. So I said one CPU and maybe 2 GB of RAM, and then I could say container web, I will give you zero point 0.5 CPU and I will give you 1 GB of RAM, and container 2 I will also give you zero point 0.5 and maybe zero point 0.5 GB of RAM, and remaining will be still available. So that is absolutely possible. You decide on how you want to further divide a task into multiple container and what memory configuration you want to add on that. All right, so I have selected one CPU and 1 GB. I'm not going to container sizes independently, so that's fine. If my task need to talk to someone else, then I may need a role on that. So I could put some roles on that. Any storage I want to connect to these container images, like I may want to connect them to some EFS mount points, I could connect it, and more information like monitoring where the logs would be collected and all, and that will help me in getting my task definition ready. So this is my container one, which will have port 80, which will be having HTTP access, and in that we have this much CPU and memory. And once it is ready, I would be creating my task definition. So what I did, I created a definition. It is like a AMI, and this AMI has to be started on a cluster now. If you want, you could deploy this task independently. So I could go ahead and say, okay, I have this task and I want to deploy it. There are multiple ways of doing it. I could go ahead from here and say deploy this task, or I could go to my cluster and from there I could say, okay, cluster, I want to run a task on you. So it is purely up to you. So currently this cluster has no task. Cluster is made up of capacity provider, which is my two EC2 instances. So that is completely fine. And I am saying now I want to create a task here. So I'm running a new task, and in that task, I would be selecting what my capacity provider and other settings are. I am interested to run a task. I would be selecting the task which I had, which is my simple web server, right? I could select different versions of it. Probably I would have just one heads up now. That is okay. And I could say, what is my desired number of tasks I want to run? I would say one is fine. If I want a group, that is okay. Placement of tasks, where it would be started, on which EC2 instance it would be placed on. So I'm selecting AZ balanced here. It could be one task per host, random, custom. There are different way of placement of the task and some additional setting. And now I say create. So now that image which I had with the configuration setting I defined is being launched as a task on the cluster. So this is my cluster, and on that cluster I have a task which is getting ready for me. It is into pending state. Maybe in a second or two it would come into running state. And what this task entails inside, if I go further into the task, it has a container running inside it. And if I want to access that and see this, what happened, my instance based on the configuration got an IP. So this is the public IP of my instance. right? And through this, I would be mapping to the container running in. So see this, there is a network binding. If my request comes on container port 80 on host, if it is coming on this, I want to forward it to port number 80 here. So if I go to this particular link and open it, hopefully it will be showing me a simple web server, and it is a web server coming up directly. So it works, not a complicated one. So what we did, we created a task, and through that task we launched the server of our choice. Similarly, you could have created a complicated solution in that, and that can be launched, should not be a problem. So I hope everyone is clear with the understanding of the task which we have just created. But when it comes to scaling and when it comes to high availability of one task fails, my application would die. And probably what I would do in that case, I would combine those tasks into something called services. So let's go ahead and talk about services now. Service is nothing but a combination of tasks. So in this case, I would again go to my ECS service and say, okay, cluster, you were running a task for me. What I am interested right now is to run a service on you. So task is running one task, and I am now putting a service. Service is nothing but a auto scaling group of tasks. So I say, okay, I want to create a service. In that, like in auto scaling, you define minimum, maximum, and desired. Similarly, you will define that too. So I am using cluster. I want to launch a service. Which task I want to select here? I would be saying I want to select the same web server task. Again, revision number. I would be calling it my web server service, right? So it looks same, but it is different in a way. And with this service, what I want, do I want replica? So yes, I want replica. I want to get started with, let's say, three tasks, or let's say three tasks. Yes, deployment option and other rolling update and all, I could select service connect. And if this is a service which may run three container, do I need a load balancer? Yes, I could. And I could have selected a new load balancer to be added for it. It will take time, that's why I'm not going through that path, but hope you get the idea. And here is my auto scaling option. Do I want to scale my service? So yes, I could say minimum number of tasks is I want is 2, and sorry, 3. Maximum I want is up to 10, and I would be using some value of CPU or another benefit or other any factors, so that I should be able to utilize these examples as per my requirement. So I am not going with target tracking and all as of now. I am not interested in getting a load balancer and auto scaling, but you could have configured it to get a better approach to your application. And now I say, okay, I'm happy, create the service for me. So what the service is basically doing, this service would be deploying three tasks for me apart from one task I'm running, and they would be spread across my 2 node cluster. If I had 100 nodes, it would spread across them, but currently I have 2 nodes. So in this case, I would have more component which are running on this. And if you see this now, see this, how many tasks I have? I have four. One which I launched manually 4 minutes ago, and others are 1 second, 4 second, and 1 second ago, and they are all running on EC2s, which is consuming one CPU and 1 GB of RAM. And if I want to exactly know which specific infrastructure they are running on, so if you see this. So currently this is my cluster capacity, minimum, maximum size, and these are the container instances on which my tasks are running. So if I go here, I should see 2 tasks on one instance, other 2 tasks on another instance. So we are leveraging same instance to run multiple containers on it. And if I have to connect to a service, probably I would have a load balancer whom I would be talking to. But in my case, I have not selected a load balancer, so I'm not referencing it directly, but I could still go to independent task within it. So see, this was my example of 3.239. That was a web server we had run. Let me go ahead here on my service web server, and let's go ahead and check the task associated with it. Let me go back. Let me pick up any other task here which is running. Let me pick this one, and let's see what is inside it. So here is still network binding information, and now I could see this one has a different IP address here. No, this is the same thing, but you could see what happens now. See this. So my instance is same, which is 3239, but previously the port number which was used in front was 32768. The second task I have is 32769, the port number. So it is randomizing the port number and still keeping the same public IP to connect. Now I won't see a difference here because it is still the same web server, but otherwise I would have seen web server which is now being displayed by same instance but 32769. And just to make sure, if you want, you could have selected any other task which is running on a different machine. Shouldn't be a problem at all on that case. So I hope everyone has a better idea of different type of tasks I could run and different type of services which I have. So when it comes to auto scaling, what you would be doing, you would be auto scaling your services, not independent tasks. I am trying to connect to another service now. See this, the service is connecting, right? All right. Pawan has a question. What is this example of port forwarding from 80 to 80 or from 443 to 8443? Now, why we need this, Pawan? Because what may happen, let me give an example here. So let's say this is my EC2 instance. We have one network interface here, right? ENI. Now, what may happen that everyone may be coming to port number 80 here because it is a web server. Now I don't want them to put all into one task. What may happen here that I may have multiple tasks, task number one, task number two, task number three. So these are multiple tasks running inside. And what I'm looking for, as soon as this request comes, I want to map it to somebody running 8080, another one running on 8081, another one running on 8082. So that mapping we could create if the need be. So this is one example. And sometimes what may happen that maybe you have a container which has hard coded value that this container would always respond on, let's say, port number 8080, but my front end doesn't understand 8080. So then I can create a mapping that, hey, if a request comes on 80, I want to forward it to 8080. So we can now have multiple port number within EC2, and outside we would have just one port number. So that's how we would be taking care of port mapping. So I hope this thing is clear. All right. And keep your questions coming. Any follow-up questions you have, let me know and I would be happy to answer. Now, what is the next question? Let me read that. Replica in a service is scaling the task. How service auto scaling is different than scaling the task? No, it is not different. It is same thing, right? So here auto scaling is happening on two ways. Let me explain that. So first says we created an auto scaling group of instances. So these are my instance number one and this is my instance number two. What we did here, we have created a auto scaling group of instances also first. This auto scaling group will ensure what if my instance 2 fails? It would then launch another instance. What if my instances run out of capacity? It would launch another instance. So here auto scaling is happening at two layers. One layer is your instance and second layer is your service. So service is also having auto scaling group, but we don't see them into EC2. They are only seen within ECS. But basically what this is saying that, okay, we would launch more containers or more tasks, and depending on if one of the tasks fails, this service auto scaling would scale up and down depending on the use case. This auto scaling group will scale EC2 instances depending on the use cases. So that is a difference what is happening, but actually at the back end it is still a auto scaling group. This one is a auto scaling group of task and this one is a auto scaling group of instances, right? That is the only difference here. All right. Any more questions here? Anyone, any doubts, any confusions, anything which is not clear? So I hope everyone is getting answer to the question and getting a better idea on how all these things work. So let's keep moving forward. And now let's quickly summarize what we have just discussed. So I hope everyone is clear with ECS, how we launch the cluster and what we have done, how we achieved this thing. And now with those services, you could perform additional thing like environment variables, and then maybe you can configure auto scaling for the service. So see this is my current status, two of them, no problem at all. This is provided by auto scaling group. And in the same cluster, you could add need more infrastructure component, which could be coming from your on-prem environment also. So you could spread your load across them, and you could collect some metrics, and you could put some schedule like, hey, I want to start some task at a particular time, so only that time they would be started, otherwise they won't be there. So I hope everyone has a better idea on basics of ECS, though it goes into much detail, but I guess you have a better understanding of ECS as of now. So what I have also included, I have included this service summary cards. So you would have access to it. So ECR, what is it? You could check this one pager about all the service details on it. Same way I have included for ECS, and then you could utilize it, and you would be using EKS here, that is also there, right? So you will have access to these three service summary card to access. Last question I'm taking here is, load balancer for ECS is built in? Answer is no. No, this is not built in. We are still using a application load balancer here. So it is not a specific load balancer we are using in this case. It is the load balancer of the EC2 instances. So if I go here and when I say, okay, I have my cluster and I have my service inside, if I want to have a load balancer in front of that, that load balancer is still a application load balancer which I am deploying. So if you see this thing here, there is load balancer optional, but this is not coming from EC2. That's all. Right. Question from load question is here that some confusion why we have replica setting in service to scale the task when it is being handled by service auto scaling. I didn't understand your question, Stockholm student. Maybe you have to rephrase it. So still some confusion why we have that replica setting. Okay. So what happens that this goes a little bit more in detail. I'll quickly try to summarize it. When you launch a service, there are two type of services we launch. One service is what we call replicas. So in replicas, what happen? You give it a task definition. So this is my task definition. And as the name is replica, we would just replicate that task for you. Right. This is one option. Another option we have is called daemon set. So daemon set work differently. Here what is happening that they all have independent entities. Daemon set is not called replica, but daemon set consider like a service running in background which is always responding to you. How it is responding, that will be taken care by the service itself. So that is a daemon set. So daemon set is also one way of deploying your services, but the most common is a replica. Replica is just an exact copy of what you have deployed, right? So that's how it will be working. Okay. In deployment, it would launch the replica and it launch the pod. Pod is a different word altogether. So let me put the question here. So Shashik, we do not use the word pods here. Pod is a very specific word used into your EKS services. So that may be a different topic. We can discuss it sometime later. But pod is not we consider in ECS. ECS, we call it task or we call it service. But pod is a very specific word which happens into EKS mechanism. Okay. All right. Thank you, everyone. And I think it is a good time to take a short break, but don't go away. We will put a 5-minute timer, and once we return, we would have a very interesting discussion with one of the guests. Let me reveal the name. Probably you have checked the LinkedIn messages. So Sanchit is with us, and in 5 minutes, we will be talking to him and understanding what he is doing, how the learning path has been on him with him and what he is contributing to the community. So very interesting story. So stay tuned and we will be connecting back in 5 minutes. Thank you.